Hello and welcome to Naughty Daddy's Guide to Computing, from Maths to Minecraft. In this video we're just going to quickly introduce the concept of binary numbers, and we're going to count in binary. Let's start off counting in decimal. Count 1, 2, 3, 4 and so on up to 9, and then we need to use another column, so we use the tens column to count 10, 11, 12, etc. When we run out of digits and we get to 99, we put 1 in the hundreds column, and so on. So that introduces us to the concept of hundreds, tens and units, which we probably learned about in primary school. Okay, so what is 100? 100 is 10 times 10, or 10 lots of 10. 10 is just 10, and units is just 1. If we wanted to go up to the thousands, we would multiply by 10 again. So each time we're going to the left, we're making it 10 times bigger. These are called orders of magnitude. So this is 10 cubed. 10 times 10 times 10, and this is 10 squared. So as we're multiplying by 10 to go up, we're adding 1 to the index here, the little number above the 10. And if we're going to the right, we're dividing by 10 or taking 1 off the index. So this will then become 10 to the power 1. And if we take 1 away again, 10 to the power 0 is our 1. In fact, anything raised to the power 0 is always 1. If we're counting in base 2 though, instead of going up in tens, we only have 0 and 1 to work with, so we're counting in twos. So it's 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 and so on. Okay, so we count zeros, this is our lowest number, and we add 1 to the units column, and we've run out of digits. So what we have to do is add 1 to the next column. Now you see 1 0 and you think, oh, that's 10. Which it would be in base 10, but 1 0 in base 2 is 2. So we add 1 again, and that makes 3. Add 1 again to make 4, but we cannot. So we've got to go into the next column. Now note, 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 squared is 4, 2 to the power 3 is 8. So what have we got here? What are we saying with 0, 1, 0, 0? We're saying 0 1s, 0 2s and 1 4. Here with our 0, 0, 1, 1, we're saying 1, 1, 1, 2. So that's 1 plus 2 is 3, and there's no 4s and there's no 8s. So that's basically how to count in binary. A little bit of computer terminology here. Whereas we call our 1, 2, 3, 4, we call them digits. Here they're not digits, they're binary digits. If I write out the word binary, digit, from the B in binary and from the last letters IT, we get the acronym BIT. So in computer terminology, when you hear the word bit, what you mean is a 1 or a 0. Each of these are called bits. How many bits you've got is called a word, or your word length. In this case, we've got 1, 2, 3, 4 to make up our number, 4 bits to make up our number. That's a 4-bit word. If you had an 8-bit long word, we call it by 8. Now, because computer scientists have a sense of humour, the 8, because it sounds like 8 having eaten something, from the, if we add the by and the te from the 8, we get bite. And not to be outdone on the puns, half a byte, or a 4-bit word, is called a nibble. Who says computer scientists don't have a sense of humour? Okay, so that's counting in binary. In the next episode we'll look at... Actually, before we go into the next episode, I do think this would be the ideal time to talk about the difference between bits and bytes. When you're talking to your internet service provider, or when you're trying to buy broadband, they will advertise their broadband speed. For example, they might say you get 100. Actually, let's say 80 megabits per second. There is a famous company that only goes up to 80 megabits per second, and their rival company goes up to 150 megabits per second, but I'm not going to advertise and say which is which. If you call around you will find out who's who. So 80 megabits per second is a reasonable broadband speed. If we want to download a file, let's arbitrarily say a file is 20 gigabytes. Okay, you often see computer memory given in gigabytes or terabytes. Some of the cheaper computers tend to have 500 gigabyte hard drives. Some of the more expensive ones can have up to 4 terabyte hard drives. So let's say we're downloading a 20 gigabyte file. By convention, a capital B is used for byte, which we'll remember is 8 bits, and the lowercase b is for bits, which is just one binary digit. So if we wanted to know how long it would take to download a 20 gigabyte file at 80 megabits per second, we're going to need to convert megabits per second to gigabytes. And this is where people get confused. They think that 80 megabits per second means they can download a 20 gigabyte file in a very short space of time. But the first thing to notice, that G for giga is 1,000 times bigger than that M for mega. So that's 20,000 megabytes. But not just 20,000 megabytes, this B is in bits, which is 8 times bigger than that B. So this 20 gigabytes, if we want to convert it into megabits, we've got to multiply by 8,000. So let's first of all convert the giga to mega. So that's 20,000 megabytes. Technically it's not exactly 1,000 because we're in base 2, so a kilobyte would be 1024, not 1000, but it's close enough that we can approximate. So this is 20,000 megabytes. Now how many is that in megabits? That's times 8, so that's 160,000 megabits. And at 80 megabits per second, if we divide this by 80, well, the easiest thing is to cancel one of the zeros out. Give myself a little bit of room here. So 8 into 16 goes 2, and then we have a 0 and 2 more zeros. So that's 2000 seconds. And what's 2000 seconds? Well, there's 60 seconds in a minute. So that's 33 minutes. So it would take just over half an hour to download a 20 gigabyte file if you had 80 meg broadband. Except remember, they don't guarantee 80 megs, they say up to 80 megs. So you're looking at a minimum of 33 minutes if you wanted to download such a file. But at least now you understand the terminology when people talk about gigabytes and terabytes and megabits and whatever. But let's just quickly go through the prefixes. Kilo is about 1,000. It's actually 1,024, but let's say 1,000. Mega is a million. Okay, so that's 1 0 0 0 0 0 0. A giga is 1,000 times bigger, so that's 1 billion. 0 0 0 0 0 0 0 0 0. And then a tera is 1,000 times bigger again. 3 1 2 3 1 2 3 and another 1 2 3. Okay, those are the kind of numbers you will need when you are talking in terms of computing. Okay, in the next episode we will look at adding two binary numbers together. See you soon.